Diagonals of a quadrilateral, specifically, are line segments that link, so line segments linking non-adjacent vertices. And what that means, I'm just going to draw a generic rectangle, and then I'll label it ABCD. The diagonals of ABCD, you would have to take each corner, and basically you're just going to the opposite corner. So adjacent sides, like A and B, are adjacent. And if I connected those, it would be the top of the rectangle. That's not a diagonal. So I would have two diagonals here, AC and BD. So the diagonals have to be inside of the quadrilateral. Diagonals are perpendicular in 3 of the quadrilaterals we talked about. Those 3 quadrilaterals are square, rhombus, and kite. The diagonals are congruent in only 2 of the quadrilaterals that we talked about, and those are squares and rectangles. If a question asks you to describe the diagonals, there are 3 possibilities that it's asking you. It wants to know, number 1, are they congruent? Number 2, it could be wanting to know if they are perpendicular. And lastly, it might be asking if they bisect each other. If they bisect each other, the way that, what that's really talking about, so if I have a square, for example, I know that the diagonals bisect each other in a square. What that means is that if you find, let me label my points. If you found the midpoint of AC, it would be here. And then if you found the midpoint of BD, it would be in the exact same point. So what they're asking you really is, are the midpoints of the diagonals the same? So let me put that down here. Are midpoints of the diagonals the same point? Okay, the main thing we're going to be focusing on, though, is if they're perpendicular and if they're congruent. So if they're perpendicular, you want to use the slope formula. And what you're looking for specifically is if their slopes are opposite reciprocals, because that means that they are perpendicular. If they're asking to check to see if they're congruent, what you're looking for are the distances. So you're going to use the distance formula. And specifically, you're looking to see if their distances are equal. If they're equal, that means that the 2 diagonals have the same length, and therefore they are congruent. I'm given a quadrilateral QRST, and I'm trying to figure out, well, I'm told it's a rhombus, and then I'm trying to show that it has perpendicular diagonals. So the first thing I notice is this word perpendicular. That tells me, since I'm looking for perpendicular diagonals, I need to use slope. Here's the formula, which you will have to have memorized for the test. It's good to draw a picture just to get an idea of what we're talking about, and make sure that you're using the right letters as the diagonals, because if you use the wrong letters for your points, you're definitely not going to get the right answer. So I'm going to draw a quick sketch. So -2, 6 is point Q. 2, 7 is R. S is 1, 3. And T is -3, 2. So here's my rhombus. The diagonals have to connect the opposite corners. So one diagonal is TR, and the other diagonal is QS. And I need to find the slopes of both of these. So I'm going to write down the points T and R. So T is -3, 2, and it doesn't matter which order you write them in. So now when I'm calculating slope, This can be my x1, y1, x2, y2. So remember, y's go on the top, so I would have 7 minus 2 over 2 minus negative 3. So 7 minus 2 is 5. 2 minus negative 3 is also 5. So I get a slope of 1. Now I'm going to move on to QS. So Q is the point negative 2, 6. S is the point 1, 3. I'm going to label x1, y1, x2, y2. And my slope would be 3 minus 6 over 1 minus negative 2. 3 minus 6 is negative 3. 1 minus negative 2 is positive 3. So I end up with negative 1. These two slopes are, in fact, opposite reciprocals, which means they are perpendicular slopes. And that is exactly what I was trying to show. I know it's a little confusing sometimes with the ones, but if you can remember that 1 is the reciprocal of itself. If I write it as a fraction, that's what positive 1 looks like. So the reciprocal of that is exactly the same, and then the opposite would make it negative. So 1 and negative 1 are opposite reciprocals of each other. Okay, we have another quadrilateral, which we're being told is a rectangle, and we want to verify that it's a rectangle by showing it has congruent diagonals. So the first thing I see here, congruent diagonals, I know that I'm going to be using the distance formula. And the distance formula looks like this, and you will have to have this memorized for the test. All right, so I'm going to draw a quick sketch and make sure that I know what I'm talking about here. So my first point is 2, 4, and that is point M. 6, 8, that's point N. 8, 6 is point O, and then 4, 2 is point P. So here's my rectangle. So very important that we use the right letters for diagonals. So my first diagonal is NP, and my second diagonal is MO. So I need to do two distance formulas here. So let me write my points down. N is 6, 8, and P is 4, 2. I'm going to label my points. So my distance formula here I would have 4 minus 6 and 2 minus 8. So that would be 4 plus 36, or the square root of 40. Now it isn't necessary that you break this down, because all we're looking to check is that they have the same length. If you wanted to get fancy, this would be 2 square root 10. But again, you don't have to do that part. And then for MO, my points are 2, 4, and 8, 6. So then when I plug this into the formula, I would have 8 minus 2 and 6 minus 4. And that grand total would be 36 plus 4 again, and that is also 40. Or again, 2 root 10 if you wanted to get fancy. So now I can see that I do in fact have equal distances. And that means that these two diagonals are in fact congruent to each other.